So up to now we have studied about the power of the lens, combination of the lenses, power formula P is equals to 1 upon focal length F, which is measured in the meter. The unit for the measure of the power of the lens is the diopter. Say, next we are going to see about the combination of the lenses. That what will happen when the lenses are combined together. So, if two lenses with the focal lengths f1 and f2 are kept in contact with each other, the combination has an effective focal length given by 1 upon f is equals to 1 upon f1 plus 1 upon f2. So, the total combined focal length which can be calculated, that as per this formula, we are having the focal lengths of the two different lenses which are combined. So, by placing the values in this formula, so we will be able to calculate the total focal length of the combination of the lenses. If the powers of the two lenses are P1 and P2, then the effective power of their combination is P is equals to P1 plus P2. Thus, when the two lenses are kept touching each other, the power of combined lens is equal to the sum of their individual powers. So, from this we can conclude that the focal length that is in the inverse, that is 1 upon f, is equals to 1 upon f1 plus 1 upon f2. As we have seen here from the power formula, that is power is equals to 1 upon focal length meter. So, as we want to combine to calculate the overall power of the particular combination of the lenses, so we just add the powers. P is equals to P1 plus P2. So, the numerical may be asked on this basis, that the focal lengths of the different lenses will be given here, and we have to calculate the overall power of that particular combination of the lenses. So it is simple that, so we can write the power, that is P1 is equals to 1 upon F1 plus P2 is equals to 1 upon F2 as per this formula. That is power is equals to 1 upon focal length. So thus when the two lenses are kept touching each other, the power of the combined lens is equal to the sum of their individual powers. Here we are having given the solved examples. So let's see that first example is an object is placed vertically at a distance of 20 centimeter from a convex. As this question is given in 5-6 lines, so we have to मतलब दो दो लाइन पढ़ने की और उसके बाद में वहां पर गिवन क्या क्या दिया है, दैट गिवन वी शुड हैव टू राइट डाउन. सो यहाँ पर जो दिया है, एन ऑब्जेक्ट इज प्लेस्ड वर्टिकली एट अ डिस्टेंस ऑफ 20 सेंटीमीटर फ्रॉम द कॉन्वेक्स लेंस. सो कॉन्वेक्स लेंस से 20 सेंटीमीटर के डिस्टेंस पे एक ऑब्जेक्ट वर्टिकली प्लेस्ड किया है. So the object distance from that convex lens will be 20 centimeter. If the height of the object is 5 centimeter and the focal length of the lens is 10 centimeter, what will be the position, size and nature of the image? So we have to comment that what will be the position of the image formation, what will be the size of the image, and what will be the nature of the image that will be formed. How much bigger will the image be as compared to the object? और यहाँ पर हमें कंपैरिजन भी करना है कि ऑब्जेक्ट की जो साइज है और इमेज ऑब्टेन्ड जो साइज है, सो व्हाट इज द डिफरेंस, व्हाट वी कैन कंक्लूड विद दैट ऑन द बेसिस ऑफ द इमेज हाइट. So यहाँ पर हमें दिया है height of the object, that is h1 we have given here, that is 5 centimeter. Then we have given here the focal length f is equals to 10 centimeter. Distance of the object u, or for the solving of this numerical we will be needing the sign convention, as the sign conventions which we have studied above, that Cartesian sign convention is necessary for the solving of the lenses numericals. So height from the height above, that will be taken as a positive, height below negative. Then distance from the principal axis towards the right are positive, distance from the principal axis that will be the towards left, that will be the negative. So as the object is placed towards the left, so object distance u will be negative. So due to this, we have taken here that object distance u is equals to minus 20 centimeter. Then we have given here the height 5 centimeter, focal length f is equals to 10 centimeter, image of the object u is equals to minus 20 centimeter. We have to find out the image distance as we have to commit on what will be the size of the image and what will be the position and nature of the image. So that we have to comment on. सो यहाँ पर हाइट ऑफ द इमेज ऑल्सो वी हैव टू फाइंड एज हाइट मतलब जो ऑब्जेक्ट की हाइट है और इमेज की जो फॉर्मेशन हाइट जो होगी सो व्हाट विल बी द डिफरेंस बिटवीन दैट हाइट एंड ऑल एंड वी हैव टू फाइंड द मैग्निफिकेशन आल्सो दैट हाउ मच लार्ज और द व्हाट विल बी द नेचर ऑफ दैट इमेज फॉर्म्ड सो we are having here formula 1 upon v minus 1 upon u is equals to 1 upon f, that is the length formula which we are using for solving of this numerical. So as we are having the u, that is the distance of the object from the lens. So that will be the minus 20. Focal length we have given here, that is the 10 centimeter. Focal length positive. यहाँ पर भी एक केस है कि focal length positive convex lens की लेनी है, concave lens की लेनी है. So as I have told in the previous part that the focal length of the convex lens that we can see here, the fifth point which is given here, the focal length of the convex lens is positive while that of the concave lens is negative. So मतलब हमें यहाँ पर ये देखना है कि कौन सी लेंस के बारे में यहाँ पर न्यूमेरिकल में बोला जा रहा है. सो जैसे कि हम देखते हैं यहाँ पर कि इस न्यूमेरिकल में दिया है कि कॉन्वेक्स लेंस इज यूज्ड. सो कॉन्वेक्स लेंस फोकल लेंथ विल बी पॉजिटिव obviously. So after putting all that values in the numerical, that in the formula of the lens formula, so we are able to calculate the v value, that is the image distance. So after putting this value and solving, we are getting the image distance as v is equals to 20 centimeter. So the positive sign of the image distance shows that image is formed at the 20 centimeter on the other side of the lens. मतलब जो 20 centimeter है, object distance हमने negative लिया था as object is placed towards the left side. So that object distance u is equals to minus 20. But image जो formed हुई है that will be the positive 20. So positive 20 कहाँ पर right side में. So right side of the lens. So image is formed and the size or height of the image is 20 centimeter. सो नेक्स्ट मैग्निफिकेशन फॉर्मूला हम क्यों यूज कर रहे हैं एज मैग्निफिकेशन फॉर्मूला इज इक्वल्स टू एच टू अपॉन एच वन विच इज इक्वल्स टू वी अपॉन यू. सो वी आर हैविंग द एच टू वैल्यू हियर. So, no, we are having the V value as we have calculated now. Then we are having the U value as it is given in the given. So, H2 is equals to V upon U into H1 as height of the image, height of the object is also given. So, height of the image can be calculated as H2 is equals to, after solving this, we are getting that minus 5 centimeter. अभी minus 5 मतलब डाउनवर्ड साइड में बनी हुई है इमेज. So magnification is equals to V upon U is equals to 20 upon minus 20 is equals to minus 1. So magnification here comes to be minus 1. So the negative sign of the height of the image and the magnification shows that image is inverted and real. मतलब जो यहाँ पर जो image formed हुई है, so as compared with the height of the object, that height of the object is 10 centimeter as it is given in the question. और जो height of the image which we have got after the applying the formula of the magnification, so we are getting here the negative sign of the height of the image and magnification shows that the image is inverted. Obviously, an image will be inverted as it is formed downwards towards the principal axis. So it will be negative. It is below the principal axis and is of the same size as the object. So the focal length of the convex lens is 20 centimeter. Was it what its power? So as I have told above that the power of the lens question will be asked, that they will be given the focal length of the particular convex or concave lens and we have to calculate the power. So 20 centimeter. So as it is given, so focal length should be in meter as the formula only states that the focal length should be in meter as it is given here. So focal length should be in power is equals to 1 upon focal length meter, which is equals to 1 upon 0.2, which is equals to 5 diopter. So the power of the lens is 5 diopter. Again, one of the important question that may be asked in the exam, that the unit of the power of the lens is diopter. This is the complete the following question which may ask. So keep in mind the unit of the power of the lens is diopter. Next, we are going to study what next topic is that human eye and working of its lens. So there is a very thin transparent cover membrane on the human eye. This is the very transparent thin membrane on the human eye, which we call it as the cornea. So light enters the eye through it. Maximum amount of the incident light is refracted inside the eye at the outer surface of the cornea. There is a dark fleshy, this is called the iris. The color of the iris is different for the different people. There is a small hole of changing diameter at the center of the iris which is called as the pupil. So the pupil controls the amount of the light entering the eye. If the light falling on the eye is too bright, pupil contracts, while if the light is dim, it widens. On the surface of the iris, there is a bulge of the transparent layers. There is a double convex transparent crystalline lens just behind the pupil. The lens provides the small adjustments of the focal length to the focus the image. This lens creates the real and the inverted image of an object on the screen inside the eye. सो जैसा कि यहाँ पर कहा गया है कि आई में जो एक थिन ट्रांसपेरेंट लेयर कवर मेम्ब्रेन होता है ह्यूमन आई में, दैट इज कॉल्ड एज द कॉर्निया. सो मैक्सिमम अमाउंट ऑफ द लाइट जो होती है, सो दैट गेट्स रिफ्लेक्टेड inside the eye at the outer surface of the cornea through this refraction of the transparent membrane cover. So there is a dark fleshy screen behind the cornea. This is called as the iris. So the color of the iris is different for the different people. As we can see here the image given. So this is called as the iris. This is the pupil, eyelid, sclera and cornea. So this there is a double convex transparent crystalline lens just behind the pupil. The lens provides the small adjustments of the focal length to focus the image. So as there is the double convex crystalline transparent crystalline lens is present in the human eye, due to which there is the adjustment of the image formation as per the requirements of the light entering into the eye. This lens creates the real and the inverted image of an object on the screen inside the eye. मतलब जो eye के यहाँ पर जो image formed होती है due to the lens which is present in the human eye, so that image is formed as the real and the inverted. So this screen is made up of the light sensitive cells and it is called as the retina. So the question asked many of the times in the exam that the image formed in the human eye is where the image is formed. So it is formed on the screen which is called as the light sensitive cells which is it is made up of. It is called as the retina. These cells get excited when light falls on them and generate electric signals. These signals are conveyed to the brain through the optic nerve. Later, the brain analyzes these signals and converts them in such a way that we perceive the objects as they are actually are. मतलब जो भी ये लाइट रेस आते हैं और जो इमेज फॉर्म्ड होती है दैट इज द रियल एंड द इन्वर्टेड ऑन द रेटिना. लेकिन ये तो इन्वर्टेड इमेज है, बट हम जब आंखों से देखते हैं सो वी आर एबल टू सी ऑल द ऑब्जेक्ट्स एज दे आर ऐसा हमें कुछ दिखाई नहीं देता. सो दिस सिग्नल्स आर कन्वर्ट टू द ब्रेन. मतलब जो सिग्नल्स होते हैं, सो ये सिग्नल्स ऑप्टिक नर्व के थ्रू हमारे ब्रेन को भेजे जाते हैं एंड ब्रेन एनालाइजेस दिस सिग्नल्स एंड कन्वर्ट देम इनटू सच अ वे that we perceive the objects as they are actually are. So this is the reason that how the human eye works. So while seeing object at the large infinite distances, the lens of the eye becomes flat and its focal length increases. As shown in the part uh, A of the figure 7.12, while seeing nearby object lens becomes more rounded and its focal length decreases, as shown in the part B of the figure 7.12. So 7.12 जो फिगर है, यहाँ पर हम देख सकते हैं लाइट coming from the distant object. मतलब जो दूर का ऑब्जेक्ट है, so the focal length will become flat as we can see here in the image. And जब nearby object होता है, so it becomes rounded. Lens becomes rounded, lens become flat. So this may ask about these two diagrams in the exam. So keep in mind that when the light coming from the distant object, so the lens becomes the flat. लेंस अगर फ्लैट हो जाएगी सो विल also गेट increase, और जब राउंड हो जाएगी सो फोकल लेंथ विल बी डिक्रीज. So light coming from the nearby object which when we are seeing, so the lens becomes rounded and the focal length decreases. So up to now this we have seen the capacity of the lens to change its focal length as per the need is called its power of accommodation. This is the definition This is the definition which we can see here. The capacity of the lens to change its focal length as per the need is called the power of accommodation. This may asked. So, although the elastic lens can change its focal length to increase or decrease it can not do so beyond a limit. मतलब एक लिमिट तक की फोकल लेंथ जो है वो एडजस्ट हो सकती है या तो डिक्रीज और इंक्रीज हो सकती है डिपेंडिंग ऑन द हाउ द लाइट कमिंग फ्रॉम दैट डिस्टेंट ऑब्जेक्ट्स और नियर बाय ऑब्जेक्ट्स. So here we are given here the human eye construction. So this diagram is definitely surely asked for the 5 marks in the exam. Answer in the following brief. So you have to practice this diagram by drawing 2 to 3 times. As it is easy, you will be able to as you will be drawing 2 to 3 times by the hand. So it will become easy for you to remember all this and try to remember the names that ciliaria muscles, then iris, pupil, crystalline lens, cornea, sclerotic coat, choroid, then muscles, optic nerve, optic disc, retina. So again, do you know here we are given that the minimum distance of an object from a normal eye at which it is clearly visible without stress on the eye is called the minimum distance of the distinct vision. मतलब एक ऐसा डिस्टेंस जो नॉर्मल आई को कि जो ऑब्जेक्ट है वो क्लियरली विजिबल हो सकता है विदाउट द गिविंग द स्ट्रेस ऑन द आई, दैट इज कॉल्ड एज द मिनिमम डिस्टेंस ऑफ द डिस्टिंक्ट विजन. द पोजिशन ऑफ द ऑब्जेक्ट एट दिस डिस्टेंस इज कॉल्ड द नियर पॉइंट ऑफ द आई. For a normal human eye, the near point is 25 centimeter. Again, one of the complete the following question may ask in the exam regards with that. So the minimum distance for a normal human eye, that is near point, is 25 centimeter. This may ask in the meter. So 1 meter is equals to 100 centimeter. So 25 divided by 100, that will be 0.25 meter. So the farthest distance of an object from a human eye at which it is clearly visible without stress on the eye is called the farthest distance of the distinct vision. और सेम जो कि farthest distance है मतलब दूर का ऑब्जेक्ट जो ह्यूमन आई को क्लियरली विजिबल हो सकता है without giving the stress on the human eye, that it is called as the farthest distance of the distinct vision. So the position of the object at the distance is called as the far point of that eye. For a normal human eye, the far point is in at infinity. So the minimum distance of the distinct vision, that we called it as the near point, so it is 25 centimeter, और जो far point का distance है that is infinity. We have given here the do you know. The eyeball is approximately spherical and has a diameter of about 2.4 centimeter. और जो eyeball होता है उसका वो spherical होता है और उसका diameter जो है वो 2.4 centimeter है. The working of the lens in the human eye is extremely important. The lens can change its focal length to adjust and see objects at different distances. In a relaxed state, the focal length of the healthy eye is 2 centimeter. और जो रिलैक्स स्टेट में जो फोकल लेंथ ऑफ द ह्यूमन आई होती है दैट इज द 2 सेंटीमीटर. अदर फोकस ऑफ द आई इज ऑन द रेटिना. सो अप टू नाउ वी हैव स्टडीड अबाउट, एक बार देख लेते कि क्या क्या हमने पॉइंट आज देखे हैं. सो वी हैव सीन अबाउट द पावर ऑफ द लेंस, कॉम्बिनेशन ऑफ द लेंस, हाउ द कॉम्बिनेशन ऑफ द पर्टिकुलर लेंस पावर टोटल ओवरऑल जो है वो कैलकुलेट कैसे होते हैं, दैट इज पी इज इक्वल टू P1 + P2. जो फोकल पावर इज इक्वल टू 1/फोकल लेंथ विच शुड बी इन मीटर नॉट सेंटीमीटर. अगर सेंटीमीटर में दी होगी सो वी हैव टू कन्वर्ट इट इनटू द मीटर. So overall focal length we can be calculated of the combination of lenses by this formula. 1/f is equals to 1/f1 plus 1/f2. Next, we have seen the magnification formula S2/h1 is equals to V upon U. Then we have also seen about the human eye and working of its lens along with the diagrams and how the image is formed on the retina and all. Up to now this we have seen. Also, we have seen the distance of the distinct vision and farthest distance of the distinct vision. These are the 2 points again which we have seen, and we have seen about the, do you know that approximately eye wall का जो diameter होता है spherical होता है, और diameter that is the 2.4 centimeter, and the in the relaxed state the focal length of the healthy eye is 2 centimeter. Next video, we will be seeing about the defects of the vision and their corrections. That is nearsightedness, myopia, then farsightedness, hypermetropia, and all presbyopia. So, if you are having any doubt regarding with all this content in this chapter, so you may ask in the live chat, and also you can comment in the comment box regards with that.